a very strange looking piece of paper on purpose. I have a plan, but you're going to have to stay with me to see the whole plan. I photocopied it weird. The intention was right now you'd pull those two pieces apart gently so you don't just rip it apart and set them side by side on your desk because we're going to be working on both pages at once. This is essentially, I just wanted to have a little fun on your last class, on your last lesson. So I set this up a little bit differently. Be like a classical investigation lesson. Now it's guided in the sense that I'm just not giving you an investigation and saying, here, you try it out and see if you realize what's going on here. It's going to be guided by me. I'm going to keep us on the road to the discovery here. However, I do encourage you to interrupt me and yell out anything you see happening. I don't know exactly how long it'll take to see what's happening. There's going to be two different things going on both of the pieces of paper. One thing I'm working on one piece of paper, one thing I'm working on the other piece of paper. And if you've already seen math investigations before, you can already guess that something's going to be related in the two pieces of paper. All right. In math, it becomes very important to be able to do binomial expansions. You've already seen some. Okay? So by the time I get to the third or fourth one, you might go, oh, I see what you're up to here. I recognize this now. And I'll do the first one. The first one is unbelievably easy. I've got to do the binomial expansion of a plus b to the 0. Now hold on. You're like, I don't even know what a binomial expansion is. Here's what a binomial expansion is. I'm going to repeat it like 11 times during the lesson so that you get a total feel for what a binomial expansion is. It's when you have two terms added together in the brackets. That's a binomial. Two terms added together. And we're expanding it by having an exponent on the outside. Thank you, sir. Now, this one's shockingly easy. Anything to the power of 0 is just 1. So I'm going to put that way over here. I hope I'm doing a good job of organizing this. Time will tell as the lesson goes on. A plus b to the 0 is easy. By the third one, you should recognize it. Okay, so if you don't recognize this one, that's okay. I'm just establishing what happens if it's exponent 0. Then I go, okay, well, what happens if it's exponent 1? And the nice thing about exponent 1 is it does absolutely nothing. Exponent 1 is just you keep whatever's in there. In fact, somebody could raise their hand right now and argue these first two aren't expansions at all. They're just simplifications. And I'm like, I know. Wait till I get to the next one, and you'll finally recognize one. We don't do a plus b to the 0 very often because it's sort of trivial. The answer is just 1. And a plus b to the 1 is very uninteresting, but please write it the way I write it. It's a plus b. It absolutely is. But write it the way I write it because I'm up to something. Yeah, of course, you know. He must have a plan. He didn't just get up out of his desk and start writing random stuff. He's got a plan. Here it is. 1a plus 1b. Write exactly what I write, and even in the positions I write it. Because this is a guided investigation. This isn't just, here, go figure this out on your own. Now, finally, one you recognize. Here's the binomial expansion that you're supposed to have a lot of experience with when it's power 2. So a plus b to the power 2. Well, that's why I don't want to mess this part of the page up too much. I want this to be beautiful. So at the bottom of that page, you'll see binomial expansion work. That's where we'll go down and we'll just work on these a little bit, okay? So this is the first one I got to do any work. So I'm going to go to the next page. It's the next page for me. For you, it's just at the bottom of the page. There. You go to the bottom of the page, and we do a plus b squared, which is a plus b times a plus b. Hopefully you recognize that one. The first one of the day where you're like, oh, I have done binomial expansions before. A binomial expansion is just when you're taking something that is two terms added together, and you've got some exponent on the outside. That's all binomial expansion is. Kyle.
Is this the unit that we were learning, like on Thursday or whatever?
This is, oh, is it the same? Are we in the same chapter?
I feel like we're not.
Oh yeah, you feel like this is not really part of the same chapter. It is, but it might take a while for you to see why it is. Yeah, okay, that's a good question. He's like, what does this have to do with Tn, Ar, N, Sn? What's going on here? Yeah, it's a good question. But hang on and see if I answer it by the end. Call me on it if I don't. Okay, so how do I expand this? This one's just FOIL. A squared plus AB plus another AB plus B squared. And incidentally, I'm already noticing there might not be enough room to do all the work I want to do today in my work thing. And that's why I copied it single-sided for you. We might run over into the other side of the page, and that's okay. A squared plus 2AB plus B squared. You should be unimpressed, I think, at this point in the lesson. You're like, okay, yeah, I think I probably could have expanded that without your crazy lesson. And I agree with you. I 100% agree with you. The key points of this lesson are coming soon. So I'm going to go back up to my top one, and A plus B squared, and see I'm writing it over here. Now write it carefully the way I write it. A squared, so I'm going to write 1A squared plus 2AB plus 1B squared. I'm writing the coefficients in there carefully. Now, here's the moment where hopefully you go, uh-oh, because you see what I'm about to do next. A plus B to the 0 was no problem. A plus B to the 1 might even be easier than the power of 0. It's just exponent 1, you just leave it alone. A plus B squared, okay, we did FOIL this year, good. Do you see what's coming next? So let's leave that on the shelf for a second before we really get carried away with what's coming next, because it's going to be bad. I admit, it will be bad. I'm going to go over here and talk about something else. Flip to your other page, and it says Pascal's triangle. Blaise Pascal was a mathematician, might also be in the Hall of Fame of mathematicians, just did all sorts of crazy stuff all over the place. You'll see his name appear all sorts of places. In fact, the grade 9 math contest is named after Blaise Pascal. It's called the Pascal contest. He was known for being very playful, just like playing around with stuff. So I want to build two images of how he might have come up with his famous triangle. It's not a triangle like you might expect. I'm not going to draw lines and make a triangle. That's not the type of triangle it is. One way to visualize the game, really, the mental game Pascal played to make his triangle, was to imagine that everywhere I don't write something, there are zeros. It's a whole field of zeros. If you want, it's a piece of graph paper filled up with all zeros. That's not really how he visualized it. He visualized it as nothing, but anytime you're looking for a number, the number is 0 that you're looking for. Then he just went up and wrote the number 1 and said, what if there was a 1? What, again, how did he come up with this? Just playing around. Just a weird math dude, a lot like Gauss, who just liked playing with numbers. He said, what if there's a 1 there? Then he said, I'm going to build a rule that every time you get a number on the next row, you add the 2 numbers above it. You're like, what 2 numbers? Like, watch. He's going to go right to this spot here, and look where I point right here. Right there, right there. I'm going to put a number right there. And he looks above on either side and adds the 2 numbers. On this side, it's a 1. And over here, what number's over here if you don't? 0. So he's going to add 1 and 0 to give 1. And then he's going to do it again beside this one. Over here, and this spot here. What number's on this side? 1. And what number's over here?
0.
Well, what number's over here? 0. So he's adding 1 and 0 to give 1. Now listen, if that is really troublesome for you, I've got another example. Instead of thinking of it this way, I want you to think of it like, have you ever seen one of those fountains where there's water dripping down at the top and it drips into a plate and then flows over the sides and then flows down? There, sort of an artistic example of what's happening here. This 1 could go this way and give a 1 over here, or it could go this way and give it a 1. Those are the only possibilities. Now, if you think Pascal's just making up random fun rules, weird math stuff here, that's exactly what Blaise Pascal was doing. He's just playing around one day, Just let me finish, Kyle. I see your hand, but I got to finish my sentences. Yeah. So was he just playing around and coming up with numbers? Yes. And weirdly, sometimes mathematicians, when they play around, what they come up with turns out to be useful. So on this page, it's just playing around. So don't get too wound up about what I'm doing. I'm just going to start building this triangle. Kyle, your question.
Yeah, what about like because eventually there's got to be a 1. There's going to be a 2 eventually.
Oh yeah, let's do the next row before you get too stressed out about Pascal's triangle. This is what his, do you see the triangle for me? Let's talk about this spot over here to the left of the 1. It's going to add the 2 numbers above it. The 2 numbers above it are 1, and what's the other number that's out here? 0. Whenever you don't see a number, Blaise, Pascal used 0. So if over here, if I go 1 and the 0, I get 1. But what's in the middle? This one here. 2. And then what's on the outside here? 1 again. Now, if you're really upset and you're lost on this, start doing this. This 1 comes from here and here. I'm not going to draw those arrows a lot, but if you're annoyed by what's happening, those arrows will help. It sort of messes up your triangle a little bit, but it shows you what's going on. And this 2, where did it come from? This 1 plus this 1. And this 1 came from this 1 and the nothing that was over here. Again, feel free to be completely annoyed by this. That Pascal's just messing around, and what do you care? You're going to care in a minute. Yeah? Let's do one more row before we go back to what we were doing, because something dangerous is about to happen. What number will be on the far left here? 1, because 1 and there's nothing else out there. How about between this 1 and 2? 3. Because we're adding the 1 and the 2. And maybe, just maybe, your brain clicked a little bit and said, oh, I can do this now. I now see what you're doing. And that's the problem with Pascal's triangle. It takes a few rows to get used to what Pascal was up to. How about here? 3, and how about here? 1. Are we good? Could you just now build a whole bunch of rows if I let you do it? Okay, we'll come back to it in just a second. Let's go back to the challenge we were dealing with. And what the heck is going on here? There. What's the next one? Here.
Oh, I'm seeing
Oh, actually, let me do one more. And then feel free to jump in and make a guess as to what's happening here. Maybe you're less than excited because you're like, clearly when he does 2 things like this, something's up. The next one's going to be a plus b cubed. Oh, this is trouble. This is trouble and what the lesson is all about. How are we going to expand a plus b cubed? I'll go to my work page and I'll do a plus b cubed, and it's big trouble. A plus b, another a plus b, and then another a plus b. So I'm going to have to FOIL out the first brackets and then do it again. This is the challenge of binomial expansions. They get out of hand in a hurry. We only got to level 3 and it's already crazy. We do have a shortcut though. That first expansion, a plus b times a plus b, I already have it. I just did it a second ago. I'm not going to redo it. I'm going to steal it from above. There it is. A squared plus 2ab plus b squared. And I'm not exaggerating when I tell you this algebra has already gotten real, this next line. Some people will call what I'm going to do next FOIL. It's not technically called FOIL. I'm not going to burn you on it or say, oh, you're wrong about that when you call this FOIL. But it's not really FOIL anymore because FOIL's first, outside, inside, last, and this doesn't. It has 3 terms and 2 terms. But you can use the FOIL thinking. It's no problem. Who's a step ahead of us here? How many terms am I going to get when I multiply this out? You're on the right thinking here. Just look here. How many terms are in this first bracket? No. 3. And 2 here. So when I expand, I'll get 1, 2, 3, 4, 5, 6. That's an important breakthrough on binomial expansions to go, how many terms are we talking about here? And there's 6. Here I go, all right? Very slowly. A squared times A, I get A cubed. A squared times B, easier than it looks. A and B are different terms, so there's nothing to write there. A squared times B is A squared B. Actually, the biggest challenge here is just staying organized. Remembering which term you're on. Next, I'm working with the 2AB, and I multiply 2AB times the A, and I get 2A squared B. And then 2AB times the B is 2AB squared. And I stop there because if I'm going to lose you, that'll be the moment I lose you. I'm multiplying the middle term by both of the terms in the second bracket. Now I'm on the B squared. B squared times A. Awfully tempting to write B squared A. Mathematicians don't. We sort of at this moment go, let's write them in alphabetical order. Let's give ourselves a chance of surviving here. So when we see B squared times A, we just write AB squared. Same thing, and they're in alphabetical order, so now we can match them up with other terms easier. Just staying organized. And the last term is B squared times B, B cubed. There's a little bit of collection I can do here. A cubed doesn't have any friends, so there's still only, if you've fallen asleep, all the magic happens in the next minute or so. Now's the time to give your head a little shake, wake up a little bit, listen carefully to what I'm going to say, because I'm going to try and say it carefully. The A cubed, there's only one A cubed, but A squared B has 1 and 2 more, so it's got 3 A squared B's.
Yeah.
Shh. AB squared, there's 2 AB squared, plus another AB squared, so that's 3 AB squared. And then there's only 1 B cubed. I'm going to go back to the top of the page and now just write that out. This was where I was doing my work. Now I'm going to go up here and fill them in. A plus B cubed was 1A cubed plus 3A squared B plus 3AB squared plus 1B cubed. Now you might notice that I was not looking back and forth between the two pages. Somehow I knew what the terms were. It's not because I'm old. I know something that we need you to know very soon.
I already see it. It's the same triangle.
I already see it. It's the same triangle. And unbelievably so. There's some really intense reasons why it's true, by the way. There's some really, really intense reasons why it works. For now, in grade 11, the first time through, we don't go after those intense rules. We just go, oh, that's handy.
Very handy.
There's a little more to the deal. Sorry, there's a few details. When I say there's a little more to the deal, you might, oh, now it's going to get tough. No, I'm almost done. But there are some details to consider. So I'm going to do at least one more. I'm going to do A plus B to the 4th for you, and let's watch what happens. Okay? In the meantime, let's go over and remind ourselves how Pascal's triangle works. Just to take a little break from all that for a second. Who wants a shot at the next layer of Pascal's triangle? 1, 4, 6, 4, 1. I'm just adding the 2 diagonals upwards. I'm just looking above on either side and filling those in. Do you see why it has to be a triangle? You're always going out a little bit. 1, 4, 6, 4, 1. Now let's just imagine we were Pascal's friend right now, and we were looking at his notes. And it was, the first triangle was 1, 3, 3, 1, and he got 1, 3, 3, 1. You're like, yeah, but does it always work? I mean, it happened to work there, Blaze, but does it work again? Let's see another one. So Blaze went, okay, let's try another one. A plus B to the 4th. And this is the one that will really establish the pattern. But we've got some algebra to do. I'll do most of it for you. This lesson is not about writing out all these terms. We're going to have a better plan than that. A plus b to the fourth. Ooh, I'm going to run out of space. Is a plus b to the fourth is a plus b times a plus b times a plus b times a plus b. Do you see the magnitude of the problem here? When you're expanding out binomials, things get out of hand in a hurry because there's so much foiling to do. Who can save us? Shh. Shh. I can hear him. Who can save us a whole whack of steps here? We've already got, yeah, he says we already got the first three. We did that already. There's one small advantage of binomial expansions. Every time you do one level, you've got that one ready to go. Shh. And if you're right with me, you're like, well, that's nice. Ooh, you saved us that. But look at this disaster. 4 terms times 2 terms. How many terms are going to be in this expansion? Lots. Yeah, but we can 8. Okay, that's a big breakthrough. If you're going to be doing binomial expansions, when will you do these? If you take data management, you'll do more of these. If you're going to be doing binomial expansions, it's nice to know before you start, how many terms am I talking about? And because there's 4 in one and 2 in the other, 4 times 2 is 8. So here we go. I'll do the first one. I'll do them 2 at a time so you can look and try to follow. Because this is not what you're supposed to do in the homework, is expand these out. This is just me teaching. Okay? But if you wanted to do it, you'd have to go, okay, a cubed times each of those. So that's a to the fourth plus a cubed b. That's the first one. I did a cubed times both those terms in the second bracket. Now I've got to take 3a squared b and do the same thing. So I get plus 3a cubed b plus 3a squared b squared. Whew, only half done. Future teachers, my job in this lesson is to do enough of these expansions that you go, I don't want to expand this like this. Yeah? I'm hoping that's about now where you're like, this is nuts. And if we had to do 5, oh my goodness. Yeah? I'm trying to convince you this is a very scary way to do these. But we can do it. Okay, next term. 3ab squared times both those. I get 3a squared b squared plus 3ab cubed. Now my morale is returning because I'm like, oh, now I have 6 of the 8 terms. I just have to do the last 2. b cubed a. You could write b cubed a, but you're going to mess yourself up when you do that. Write them in alphabetical order. So I get plus ab cubed plus b to the power of 4. Whew. That's a mess. But there is some cleaning up to do. And if you've drifted off to sleep, or if the algebra of that is more than you were hoping for on a Monday, then tune in for this line, because this line might get your attention. A to the fourth. Is there any other a to the fourths? No. There's only one of those. A cubed b. The first term is a cubed b, and then I have 3 more of those a cubed b's. So that's 4 a cubed b's. Next terms are a squared b squareds. There's 3 and another 3, which is 6 a squared b squared. You can imagine right now, Pascal is like, whoa. 1, 4, 6. Will it continue? Of course it does. 3ab cubed plus another ab cubed is 4ab cubed. And then finally, 1 of the b to the 4th. Did it work? It did, of course. Well, that's the unfortunate part of guided investigations. You're like, it's going to work or he wouldn't be doing this. Math doesn't always work like that in history. Not everything works out, but I'm showing you what happened in history, so it nicely works out. Give you a minute to make sure you got that copied, and then I'll go up to my top of the page and fill that in. Do you need more time there? So I'm going to go up here and fill that in. 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the 4th. It's not quite as easy as it looks. There's a little tiny bit of trouble looming. Without going to the other triangle, and I'm going to pause. Sorry, video people. I'm going to pause for just a little bit here and let you stare at the numbers and the variables and everything that went on. I'm hoping there's somebody who right now can take a shot with this. If you make a little mistake, I'll be there to help. And when you see them do it, then you can start thinking about if you could do it. Because there's something else. There's something more than the numbers going on here. Esther Rose. She says. She's got it. Go.
It'd be 1 to the power of 5. And then
Yes. I'm going to let her continue. But hopefully most people agree with that one. What's the next one?
and then would it be 5?
Yes, 5. Hold on. That's the easier part. Let's not call that easy, but that's the easier part. She picked off the coefficient. Picking off the coefficients, that comes right from the triangle. And you can get it right from here in this case, but you're probably going to get it right from the triangle. Now the pressure's on. This is the tough moment. What are the A's and B's?
The A's and B's would it be like
A4 is correct. And after we find out from her what the B is, B, oh yes, I see what you're saying there. B3. Is it B3? Which one is it? Oh, hold on. There's a mistake in my line. That's why it's not working. I gave you no chance, Esther Rose. I got distracted while I was doing this. Fix your note, please. There's a mistake right there. And I need this small eraser. Hang on. Let me just fix what was there because I put an incorrect exponent there. I got a little carried away. Whoa. Yeah, let's fix it together, shall we? Well, it was just a copying error, wasn't it? It was a cubed b was the correct thing. That was incorrectly copied from our work.
So we're just saying that.
Yes, just a b. Now, if you're completely lost, don't worry. There's a very specific pattern going on. And it's actually, I think, easier than what's going on with the coefficients once you see it. Does she see it? What's the next one? What's the coefficient? 10. Most people, I hope, are getting the 10 now. What's the power on A? The first term was 5. The second term was 4. 3. There's the specific pattern. The A's just keep going down by 1. How about the B's? Yeah, B2, or B squared. Yeah? So the B's are just coming up. So you start with all A's. The A's reduce the whole time, and the B's come up the whole time. Yeah? Well, once you see it, it's not the worst. How about the next one? What's the next coefficient? 10. Where are we at with a's? A squared, because the a is just reducing, and b cubed. Next coefficient, 5. What's happened to the a's now? Reduce it down to a to the power of 1, which you can just write a. B's now up to 4. And the last one is 1b to the 5th. I can do even better, friends. Look at each term, the exponents in it. What do the exponents add to in each term on that line? 5. Because one's going up, one's coming down. So there's a little more of this than meets the eye, but it's all nicely patterned. Is it right? Let's go back to Pascal's triangle. Who wants a shot at this? Forget about what we just did. Who wants a shot at just building the next line of Pascal's triangle?
One,
Yep.
5,
Yep.
10,
Yep.
10,
Yep.
5,
Yep.
1.
Once you have that down, things go pretty quickly. Once you can build the one line in it. We'll go one more line, and then we'll use that line to try and get one more line on our other triangle. So this is 1, 6, 15, 20, 15, 6, and 1. You're just adding the two numbers above. And we'll use that to go back and build one. Ooh, it's going to be tight on mine. I don't know if you've got enough room or how you're doing on space, but that's why I gave the back. It's going to be 1a to the 6th. And if you really want to know what's going on now, the first term always has the exponent of whatever your expansion is. After that, you just use the coefficients of Pascal's triangle to get the coefficients. So this will be a 6. And the a's start reducing in power. The b's start increasing in power. So this is now a 5th with a b. Now, is there somebody who can just whip them off just that quickly now that we're that far? Palmer.
15a4 b2, 20a cubed b2, 15a squared b4, 6 plus 6a b5 plus b6.
I'm going to write the 1. And the fact that you did it quickly, don't let that intimidate you. Let that inspire you to go, oh, there's some specific patterns here. Let's establish the exact 3 patterns there is. The first pattern is the coefficients, straight out of Pascal's triangle. If you know how to build Pascal's triangle, then you can build the coefficients. The a's start with whatever exponent you were given and reduce by 1 all the way across until they disappear at the end. There's no a in the last term. The b's start with nothing and start going up by 1, b1, b2, b3, whoops, b4, b5, b6. Easy to check too afterwards. You make little mistakes like I did, you can go back and check and follow it all the way along. I only have 2 examples to do. And if you've seen the homework, you see it's not a long list. You just have to do this with some other terms. But if you're looking at the list right now, you're like, wait a minute, you clearly have not explained something yet. And that's true. I'll show you what it is. The first one example I'm going to do in examples is going to be a plus b to the 7th. Let's pretend that appeared on your test. What would you do first to get yourself ready to do this question? Build Pascal's triangle. Just on a separate sheet of paper, you go over and say, let's build Pascal's triangle all the way down to the 8th level. 8th level. Why is it the 8th level? It starts with the 0th level. That's exponent 1, exponent 2, 3, 4, 5, 6. So it's always one more than you think. So, as we go across, here comes the 7th level. 1, 7, 21, 35, 35, 21, 7, and 1. I'm just adding the two numbers above the outside ones. You add 0 because there's no number above on the other side. Now that I have those coefficients, I already know the coefficients all the way along. And I'm going to do it a slightly different way. I'm just going to write those coefficients out. I'm going to go, the first one's going to be 1 plus 7 plus 21 plus a 35 and then a 35, then a 21, and then what often happens in these, you got to go to the next line. I'm just going to write the coefficients out. This doesn't work for everybody. Some people would rather do individual terms, but some people like this better. Now let's talk about the a's. What's the highest exponent of a? 7. So you start with a7 here. And instead of doing the whole term, some people might feel better going, I'm just going to get all the a's down now. Starts with a7, next term will be a6, then a5, then a4, then a3, then a squared, then a, and then no a's. So you know you've picked the right level when you get to the end. You go, yeah, the last term doesn't have any a's. Then some people do the b's the opposite way. They go to the end and go, the last one will be b to the 7, and go backwards, reducing the b's all the way. Some people like to see that pattern better. So then I go, okay, this one's b6. This one's b to the 5. This one's b, oops. This one's b to the 4. This one's b cubed. This one's b squared. This one's b, and the first one has no b's. I feel great about the pattern. Final check. Do all the exponents add to 7? 7, 7, 7, 7, 7, 7. That makes me feel good when they all add to 7 like that. That was example 1. Here's example 2. And if you've drifted off to sleep and go, I got this, it's so easy, you might want to check this one out. Okay? Oh, yeah, I could jump to 20, but I'm not sure. 7's about the most I've ever put on a test because 7 establishes, do you know how to build Pascal's triangle? Okay? This is what we really want to accomplish today. 2x minus 3y to the 5th. I encourage you, when they write that, to go, relax, settle down, and just go, I'll just do a plus b to the 5th. Let me get that down first. I can do that reasonably easily. Now, hopefully, you go to Pascal's triangle to the 6th row, because there's a 0 in the table, right? So the 6th row is 0, 1, 2, 3, 4, 5, the 6th row to get the 5th expansion. Did I count wrong there? 3, 6, yeah. 1, 5, 10, 10, 5, 1. Okay. 1, 5, 10, 10, 5, 1. I'll do it the other way this time. Some people might like this better. When they do the terms individually, they go, okay, if it's a plus b to the 5th, I start with a to the 5th. Every term after that, the a power goes down by 1, and the b power comes up by 1. So I get a to the 4th, b, a cubed b squared, a squared b cubed, a b to the 4th, and b to the 5th. I'm in that club. I like doing the terms better than what I did in example 1. But I don't say that's better. That's just what I'm used to doing. That is not what they asked for. That's a plus b to the 5th. What do I have to do with that to make it into 2x minus 3y to the fifth? See, a wasn't a. A was something else. A is 2x. So let a equal 2x. I'm going to do the exact same line, but everywhere I see a, I'm not going to write a. I'm going to write 2x. What's the b? The negative 3y. Yes, you need the negative in there because we did it all with adding. So this is the part you're not going to like. The rest of the lesson is like, hey, that's pretty good. I can do that. This part makes a big mess. Here it comes. 1, 2x to the fifth. And then 5, 2x to the fourth times a negative 3y. Then a 10, 2x cubed and a negative 3y squared. And another 10, 2x squared, negative 3y cubed. And then 5, 2x, negative 3y to the fourth. And then finally, negative 3y to the fifth. That is long and boring to fill all those a's in as 2x's and all those b's in as negative 3y. Then it gets real. Dealing with these individual terms. I'll do it on 2 straight lines. But I do want you to ask questions if you're curious about where I'm getting these numbers from.
Yeah, the exponents to the brackets.
Oh, give that a look for a second. Or get it copied down first, and then we'll talk about what happened there. Because I used some, the timing's good. If you did your first page of exam review, you got to review some of this. But we're going to go through each term and figure out what happened, okay? How did 2x to the fifth become 32x to the fifth? The exponent loss. 2 to the power of 5 is 32. Putting exponents on regular numbers is still no big deal. It's the same rules as it always was, 2 to the exponent of 5. But when you put an exponent on an x like that, you get x to the fifth. That one's not too bad. Next term, 2x to the power of 4. The 2 gets power 4, which is 16. The x gets power 4, which is x to the fourth. Next, the 2 gets exponent 3, which is 8. And the x gets exponent 3. But the same thing is now happening with the y's. Negative 3 squared is 9. And y with exponent 2 is 2. So hopefully you can see that's not really, it's long, it's ugly, and it's scary looking. But it's not all that bad to get those individual exponents. After that, last line is just combining the coefficients. So I get 32x to the fifth. And that's 80, that's minus 240 x to the fourth y. It's the last example, so I got to check these before I wrap up the video. 720 x cubed y squared. Oh, 4 times 27 is 108. Oh no, negative. Well, that's interesting. Negative 1080. X squared y cubed. I'm going to check these for errors in just a second. 810, well, that's interesting. Xy to the fourth Oh, and this one's not too bad. Negative 243y to the 5th. Let's check all those, though. Maybe I'll check it with my calculator just to make sure I don't have a video mistake here. It's horrifying when that happens. Add 2 power 5. Yes, 32. 5 times 2 to the 4th times negative 3. Negative 240, yes. 10 times 2 to the power 3 times negative 3 squared. 720, yes. 10 times 2 to the power 2 times negative 3 cubed. Negative 1080. Oh, things are going well here. 5 times 2 times negative 3 power 4, 8, 10, and I'm pretty confident about the last one, but I will type it in. Negative 3 to the power 5, negative 243. Please notice a couple of things. One is the x's and y's still did follow the pattern at the end. x5, x4, x3, x2, and the y's came up. Does anyone have the homework page? So I can put a warning. I forget what the hardest question is in the homework, but I might have to give you a warning about one of the questions, if it's there. I don't know if it's there or not. G, we, D, we, D, yeah, that's nice. G, J, and K are for reals. You're going to have to really focus to land G, J, and K. The other ones, not too bad, okay? Especially the first couple. Any questions there? I see a couple of frowns. Who's got a question? I'm not acting like it's easy, but I need to know which part I need to explain more.